Good day, everyone. This is Dr. Lin here. Today, I'd like to talk about access control and authentication. One of the fundamental principles on which computer security is built is that of controlled access. What this means is that a user cannot simply do whatever they want. Instead, a user, which might be the person or a system, is granted authorization to perform specific action on specific digital access. As a user, a database, for example, the database administrator might grant you the right to read, modify, or delete certain data within the database, while other part of the database might be inaccessible or limited to you. A critical point to understand about this controlled access paradigm is that the success or failure of the paradigm hinges on knowing exactly who a person or system really is. That is, if an attacker seeks to impersonate a legitimate user and is successful in their impersonation attempt, then the controlled access paradigm has failed. And this is because the attacker has convinced the system that he or she is a legitimate user and is therefore circumvented our efforts. It allows only authorized parties to perform action on our digital assets. Impersonation then defines the act of pretending to be another person or another entity for the purpose of entertainment or fraud.
We'll look at the general concepts first, and then we'll go through rather quickly 3 different approaches to access control: discretionary, role-based, and mandatory. This is not a long topic. We'll have a few examples as we go. A definition of access control: the prevention of unauthorized use of a resource, including the prevention of a use of a resource in an unauthorized manner. So stopping someone from using a resource that they are not allowed to use, or to use a resource in a way that they're not allowed to use it. What do we mean by a resource? Can anyone give me an example of a resource? A resource. With respect to a computer system, what resources do we have? Database. Others? What are the resources that our computer system offers our users? Files. Okay, a file is a resource. The things that it provides. Files, we can think of processing, so the ability to run a piece of software. We can think that piece of software executing is a resource. Memory in some cases. So the parts of the hard disk, the access to the CPU and the different operations that that computer system provides. So we want to control who can do what on our computer. Who can access which files? Who can run which software? Who can start different peripherals on the computer? Who can start and open the CD? Who can access any other devices attached to the computer? So by resource, it can be not just files, it can be physical resources as well. In many of the examples, I'll refer to files because they are commonly the resource that we want to control, but there are others as well. Any questions? We're only on the definition, but there's still a lot of talking. Suggests it's a bit confusing. Confusing? Okay? All right. With respect to what we've seen in authentication, access control is another function involved in our computer system. So we can think in our computer system, we have a set of resources, files, databases, memory, portions of memory, and so on. So to control which users can access them and do different things with those resources, well, first we need authentication of the user. That's what our previous topic was about, saying how can we check that this person is an authentic person with respect to our computer system, that they have already been registered and that they are who they say they are. So we've looked at means of authentication. Once a user is authenticated, for example, they log in, then we have an access control function to say what this user can do with respect to our resources. So once someone logs in, the access control function may say that this logged in person, this user with this user ID, can access these resources. And we'll talk about what we mean by access shortly. So for access control to work, we of course need some authentication first. We need to make sure the users are who they say they are, because most access control functions depend upon the user ID. Okay? That is, we say this user can do these things. So we need to make sure that we've got the right user. And the access control function will do things like say this user can access these resources. And it will control and make sure that the appropriate user can access the appropriate resources. To do so, there needs to be some database that says who is authorized to do what. So some authorization database that says these users are authorized to access these files, for example. Who sets that up? Whoever is managing the computer system. Here in the picture, some security administrator. So someone sets up the authorizations saying which users can do which things. The access control function is a software that checks based upon the user that's authenticated and logged in and controls and makes sure that the authorizations are implemented correctly. That is, the user can access the right resources. So we've got different components all coming together now. And last thing, we want to make sure that all of this works. So let's say we have an authentication system and an access control function that controls, say, that the students can only access a subset of the files on our server. So the administrator of the server has set up a database saying that these are the students in our computer system, these are the files that they can and cannot access. Auditing is the process of checking that all of that is working as intended, to confirm that the access control is working, that the database is correct. So auditing is checking that once we've set things up, that it's working as intended. So overall we need, we're going to focus on access control, but for that to work we need authentication, and also to check that it's working correctly we also have auditing. So the other functions in addition to access control we need is authentication, check the credentials of the user that's trying to access the system. That's the previous topic. Authorization, so someone needs to determine who can do what. So we grant permissions or rights to users. And when I talk about users in terms of the computer system, it says he is granting a right to a system entity. It may be a piece of software. I say that this software can access this file. And that software may be running on behalf of a human user. And auditing is some review of the system to make sure that it's working as intended. So checking that the controls are working correctly, that if we have some policy, say in our organisation, that says students cannot access the financial records of SIT, that may be an organisational policy, then we need to check that our access control implements that policy correctly. And detect breaches if something goes wrong, then be able to detect that and fix things when things go wrong. That's the role of auditing. We're focusing on access control, the fourth one in that list. There are three main approaches to access control listed here: discretionary, mandatory, and role-based. We'll talk about each of them, but as a summary, discretionary access control is the one that we will be most familiar with already. It involves, we identify who's requesting to access a resource, and we have some rules to say what they can do with that resource. So we need to specify those rules, and it will allow entities, for example users, to modify those rules. For example, to change who can access particular resources. An example may be, I can access one file on the computer system. It's my file. I've created it. I may be able to change the access control so that I'll allow other users to access my file. I have the discretion to change the controls. Mandatory access control is slightly different in that we cannot change the permissions or the access controls once they've been set up. And we'll go through that, and that's similar to what we'll see is security clearances, like things in the military are top secret, secret and confidential. And we'll talk about the relationship between different security levels and how they can be implemented in a computer system. We'll see role-based access control is similar to discretionary access control, except instead of controlling which users can access resources, we do it based upon user roles. For example, we say all faculty members, the faculty member is a role. I'm a user, but I may take a role of faculty member, and we specify the controls per role. So I say all faculty members can do these things. All heads of school in SIT, there are multiple people who are faculty members and heads of school, they have different access permissions. So a user may take one or more roles, and in role-based access control, we control based on the role that they have. We can mix them. So a computer system may combine these three different approaches. You don't have to use just one or the other. So let's go through them, but first I think some basic things which are common across all of them. Actually, requirements we'll return to after we go through some specifics. So we'll return to this list later. Let's go through the basic elements of access control. So all of these systems, we distinguish between a subject, an object, and an access right. The subject is the entity trying to access a resource. Think of a person or a piece of software acting on behalf of that person. So a subject wants to access some resource, and that resource we refer to as an object. So the thing that we want to be able to access and control access to is we refer to as objects. And those resources or objects may be some record in a database, some blocks that is on the hard disk. A hard disk is split into blocks, so a particular range of blocks that they can access. In memory, we can divide memory into pages, for example. Files, so the object may be an entire file or even part of a file. So we may control very fine-grained and say that this user has access to these parts of this file, not just the entire file. Directories, email boxes, for example, as the inboxes for different users, software, so programs, and communication ports or means of communication on the computer system. So there are many different types of resources, or what we'll call objects when we talk about access control. What we want to do is specify which subject can access which objects. And we do so by specifying access rights, or sometimes called permissions. We say subjects have rights to access different objects. It describes the way in which the subject can access the object. So when we say access, it may be different ways. So common ways are read access. Read, for example, on a file means you can see the contents. If I can read a file, I can see the contents of that file. Write access means I can modify the contents of that file. Execute access, the access right of execute, means I can run that file, execute it. And there may be others like delete. I may be able to have the specific right to be able to delete the file or not be able to delete the file. Create files, search for files, and there are even others. So there are different things that we may want to allow the users to do. They are called access rights. In summary, we want to specify which subjects have which access rights on which objects. For example, user Steve has the read and write permissions on file X. Questions on these three concepts? Easy so far? And some of you may have seen these concepts in Linux file systems. If you've sat through our lab, you've seen that we've been able to give permissions to users. And that's what we're talking about here, but in the general concept. So the most common form that we'll be familiar with is discretionary access control. An entity may be granted access rights that allow that entity to enable others to access the resource. For example, I may be able to read and write to a file, and I may also have the permission to give someone else permissions to read and write that file. So we can modify the permissions or the access rights. We have the discretion to do so. That will distinguish from another type where we're not allowed to modify them once they're set up. That is, just going back to our picture, there's some initial authorization database that says that these subjects have these access rights on these objects. But with discretionary access control, the users, the subjects, may change that. So they may modify those access rights as we go. Not the security administrator, but the actual users may change the authorizations. It's very common in operating systems and in database management systems, which is what we're mostly familiar with. We use operating systems all the time. We need to set them up for different purposes. And I think some of you have implemented different databases or database management systems to control what users can do. And as a result, the concepts are also applied in many applications you may develop, like websites, where you have multiple users and you want to control which users can do which things. What we do with discretionary access control, we specify the access rights. We map for each subject to each object on the system. We say what access rights they have. And we can think of that as a matrix, an access matrix. Let's go to an example, a simple example that says we have a set of three subjects, three users on our computer system, for example, A, B, and C, and we have 4 objects. This is, of course, a trivial example. In a computer system, we have we may have many more objects and may have many more subjects. But the access control can be implemented by specifying in a matrix form that of those objects, what can the subjects do? And the objects in this example are files. So in the element on the matrix, it specifies the access rights. So subjects, objects, access rights. In this example, it says user A owns the file 1. So that's some access right to say that they are the owner of that file. In addition, they have the right to read that file. The access right or permission to read the file, and also the permission to write the file. User A has no permissions on file 2. Being empty means that those access rights are not available. And they have own read and write on file 3 and no permissions on file 4. And similar for user B and C, we see the access rights for this system. So this information is what's initially stored really in the authorization database. So think of the authorization database specifies which subjects can do which things with which objects. And here we're doing it as a matrix. This is just an example on files. It doesn't have to be on files. It can be again on memory, parts of files, different resources inside our computer. Files is the easiest example and the most common one we see. In this example, read implies that we can see the contents of the file. Write implies that we can modify the contents, which often also means we can delete the file. Let's say it's a text file. If I'm allowed to modify the contents and save it, one thing I could do is just delete all the characters in the file and save it as an empty file, which is almost equivalent to deleting the file. So write sometimes implies that it also means the ability to delete an object. What do you think ownership means? If I own a file as opposed to not own, what extra thing can I do? What can user A do to file 1 that user C cannot? Well, if we say that write permission means that we can think of, write means you can modify. So I open up the file as user C. I'm allowed to write the file. It says user C can write the file. Then I open the file in my editor and I remove all the characters and save it. That's effectively deleting the file. There's nothing that's left. So no, not necessarily delete. It depends upon the exact implementation. Maybe there's another thing that user A can do but user C cannot in discretionary access control. What do you think the own helps for? Delete and remove are about the same.
But deleted file still exists.
Right, but the contents of the file are gone.
Okay.
Maybe the file name is still there, but there's nothing in it, so it's effectively deleted. What else? Ownership, what can that provide me? Ownership generally implies that I own that file, and in discretionary access control means that I have I'm allowed to change the access rights on this file. That is, I may change it for myself, and more importantly, I may change the access rights for other users. Since I own file 1, user A owns file 1, user A can allow user B to also write it. So they can modify this set of permissions. Or they could modify the permissions for user C that user C can no longer write file 1. So in discretionary access control, the users have some discretion in modifying these permissions. And usually that belongs to ownership. The owner has the discretion to modify the permissions for that object. Think of your computer or a computer system that you use. There may be multiple subjects, multiple users. How many files on a computer system? 4 or more? More, many more. Okay, so there may be many files on a computer system, and so our matrix gets quite large in this direction. There are thousands, maybe millions of objects that we want to specify. So thinking of it as a matrix becomes a bit complex, because you may find that many of those files or objects users have no permissions. So it becomes a lot of these empty elements in here. So there may be many files that one user may have permissions, other users can do nothing with, which is common in practice. So that instead of thinking of it as a matrix and even implementing it as a matrix, usually we condense this information into a list. So there are what's called access control lists. This is the exact same set of permissions, but represented in a different data structure. Instead of as a matrix, we have a set of lists. And in this case, there's one list for each file, each object. File 1, in some list or some linked list, we say that user A has the permissions of own, read and write. So R and W just a short for read and write. User B has the read permission and user C has the read and write permission. And you check, that's for file 1, that corresponds to the first column. The information in the first column is stored in that list. So it's exactly the same information, it's just a different way to store it. Because this information needs to be stored on our computer system so that, think of it as this authorization database, it needs to be stored here so that when a user tries to access a file, our access control function will check that and determine if they can access it or not. So the way that we store that is actually important. There are different approaches. So access control lists, for each object in our system, they specify what different users can do with that object. So for file 2, user B and C can have different permissions. User A is not in this list. So we only list the users that have some access rights. Those that have no access rights are not listed. And that saves on the storage, really, or the managing that system. So if we have 1,000 users in our system and only 2 users can access file 2, then we just have these 2 entries. We don't need to have entries for all the other users, because it implies that if the user is not in this list, it means they have no access rights. So it's just a more condensed way to store the information about the access rights. Access control lists. For each object, list the permissions for each user. And the alternative is a capability list. For each user, list the permissions or the access rights for the different objects, what capabilities they have. And this is exactly the same as our original matrix and also the access control list. It's just a different data structure for storing this information. User A is allowed to, or they own file 1 and they can read and write file 1. They also own file 3 and can read and write. All the other files on the system, they don't have any permissions. So this is, for example, if we have 1 million files on the system, then we only need to deal with entries for the files that user can actually do something with. We don't have to worry about others. And user B. So just check that the data in these 3 representations are the same. Okay? And if you see that, really look at the column, file 1, and that's the access control list. If we look at it row-wise, So user A, that's the capability list. And in fact, different systems will use either usually access control lists or capability lists. The matrix is usually inefficient for storage and for updating. Or a fourth option, an authorization table. Simply a table saying a row for each combination of subject, object, and access right, or in this case, listed access mode. So again, same data as the previous three. Subject A, user A, has the access right of own on object file 1, and so on. So a table that has a row for each access right of combinations of subjects and objects. Here it's listed access mode. It's just another name for access right, the mode at which we can access that object. Authorization table, capability lists, access control lists are commonly used in practice, but they are all just more efficient ways to store an access matrix. So they are listed there, those three alternatives to the access matrix. Easy so far. Let's go to an example. And I think some of you have seen the example before, but we'll spend some more time on it, just to be clear. And the examples we'll use for access control are on our Linux operating system. We have a set of users on this system, and we saw them yesterday, but just to remind you who's there. Password is the file that stores the user information. And there are many users on this system. In fact, each of you are a user on this system. So your usernames are there. And in another file, in the shadow file, is the password information. How is access control implemented on our Linux operating system? Where do I find out which users can access which files? How do I know? How do I know which user can access which files? Can any user on my operating system access any file? No, there is some permissions that control what a particular user can do. And we've seen it before, we'll do it again. If I try to look at the file that stores the password information, it's called shadow, it's in the etc directory, permission denied. That's access control working. The access control function is checking. The object is the file. Shadow is the file name. That's the object. The subject is the current logged in user, which is network. I'm currently logged in as user called network. So the subject called network is trying to access, read the file shadow. The access control function is checking before they allow them to do, and it checks and it finds out, no, they don't have the access right to read that file. So our operating system has this access control function built in. How can we see the matrix or the access control list? How do I know which files I can and cannot access? ls minus l. If we list a file, there's different ways to do it. ls minus l just lists the file information in long format, and it tells us some information about the permission. So this is the file, and it tells us, and we'll recap, these 9 characters tell us in short form the permissions on this file. For this file, The user that owns the file is called root. That's the owner of the file. That user has the permissions of read and write, but they do not have execute permissions. That's how we interpret those three characters. RW dash means R for read, W for write. The third character should be X for execute. If there's no character there, just a dash, it means we don't have that permission. So the root user has read-write permissions on this file. But there's a separate classification of users. There's also a group of users. The group is called shadow. Anyone inside that group has these permissions. Anyone inside that group has the permission to read the file but not write or execute. And anyone outside of that group has no permissions on that file. The network user is in these groups. They are not in the shadow group. So the network user is not the owner. They are not in this group. Therefore, they're one of the other users, the other set of users, so that the permissions that the network user has on that file is defined by this settings, which means they have no permissions. They cannot read, they cannot write, and they cannot execute. That's why when we try to look at the file, it says permission denied. So the access control function uses this information. So somewhere it's stored on the file system, and it checks the permissions, and when someone tries to open the file to read it, the access control function of the operating system does the check, and in this case determines they don't have access. So that's an example of the access control in operation. Is this system discretionary? Discretionary access control? What's discretionary access control mean? I know we haven't looked at the other two, but what's the discretionary part? Why do we call it discretionary? What's it mean?
Dimension of user and resource.
No, not. Think of the word discretionary. Discretionary, or the users have some discretion to do something. It means, discretionary means that the users can choose to change the permissions. They have the discretion to make changes, really. So in other systems, we'll see later that the users cannot change them. Once the permissions are set, so once the initial permissions are set, the users cannot change that. But in a discretionary access control, a user has the ability to change these permissions, especially of the files that they own. And we can do this in this system. Let's switch to a different user. Any volunteers? Who's going to volunteer? Okay, thank you. Can you tell me your password? I want to switch to this user, but I need his password. You want to guess? Brute force. Failed. Our authentication is not working. Is working in that if you type the wrong password. So this is back to our previous topic. Note when I typed in the password, and I'll do it again. I think we've seen this, but we'll do it again. All right, it prompts me for the password. I type in a password. I know it's the wrong password. I press enter now. It takes several seconds before it returns me to it says there's a failure. It doesn't say wrong password or even wrong username, but in this case it's just saying it didn't work. And importantly, there was a delay. So when I pressed enter, until when it returned me to try again, there was a delay of several seconds. It doesn't take my computer long to check. It takes microseconds to check. So the delay is some arbitrary or some introduced delay to make it slow for brute force attempts. It means someone cannot try many passwords. I need to remember or try and guess the password. I'll try again. If I keep trying, do you think it will lock me out? No, on this system, I think I've done it again. If you keep trying, it will just allow you to make multiple attempts by default. Maybe I don't know the password. Okay, we're there. So, we're logged in as a new user now. Okay, let's create a file. I made a mistake, didn't I? So in this case, our user has permissions on this file which are read-write. The user that owns it has read-write permissions. The group, anyone in that group, has also read-write permissions. Anyone else has read permissions. That's how we interpret. Anyone else, it turns out by default, no one else is in this group other than the user. So the default permissions say that for this file, the user is allowed to read and write. Everyone else is allowed to read the file only. They cannot modify. So they're the default permissions. We can change permissions. How do we change permissions? Question? chmod?
What if you
Yeah.
write to 000 and you're not pseudo user?
Again?
What if you set the write to 000?
All right, let's change the permissions and see some things that we can do, okay? Well, we may, we'll see the role of ownership. So let's change the permissions and we'll make some different changes and see what can happen. We can change permissions with this command, change the mode at which people can access. So in an access write or an access mode. And we can say, for example, others cannot read the file. Subtract the write or revoke the read permissions of that file. And we'll bring up another user. And our other user I'm logged in as another user now. Can they read the file? Let's try. Permission denied. So this my alternative user cannot read the file, and if we change the permissions back, others can read the file. We now can read the file. So that's just changing the mode of the file, which is this discretionary part of discretionary access control. The users have some ability to modify the permissions. What do you want to do? Remove the permissions for everything.
Yes, and if you're not pseudo user, you can't.
Let's see what we can and cannot do. Can this user change the permissions? Let's try. No. Okay, so normally the user that owns the file has the ability to change the permissions. A user, in this case our user has the ability to read the file, but they don't have the ability or the discretion to change the permissions on that file. Okay, so that's usually the role of the owner, why we often specify the owner. The owner can change permissions, but other users, even if they can read the file, cannot change the permissions on that file. Everyone cannot do anything. A, for all users, subtract or revoke the permissions of read, write and execute. Permission denied. And my other user, of course, cannot do anything. What happens now? So the person who owns the file cannot even read the file. That's a problem. But the owner can still change the permissions. So there's this fourth access right we have here, ownership. So now, previously the owner could not do anything with the file, but they're still allowed to change the permissions. So we change the permissions back so that we can now read the file. So that's the normal case, in that a user can change permissions if they own the file. So think of 4 access rights so far: ownership, read, write and execute. And that's what's default on a Linux system. On other systems they may have other access rights and different meanings. So what we're going to do, your next homework task will involve just looking at permissions, and that's where you'll need to use one of these virtual network nodes so that you all have the same setup. And what you can do is create some users, some fake users on your system, and I'll give you some tasks to change permissions and just explore what you can and cannot do with discretionary access control.
Who does what to what based upon a policy? And we've already discussed security policies, these things that need to be worked out by organizations prior to them being implemented. So essentially, access control is who gets in and out of a system, and who uses what resources, when, and in what amounts. If you think about it, that's a lot more complicated than what we discussed in the Linux administration course. And it'll make a lot more sense when you see that access control is not just something that simple, or it doesn't necessarily need to be that simple. So elements of access control consist of the following 4 things. There are subjects, objects, operations, and something called a reference monitor, which I didn't discuss previously. Now we already think about subjects are going to be the users, as we discussed in Linux administration. So what are objects? Well, objects pertain to something just as simple as files, but that could be other types of resources, such as getting access to the printing server or getting access to a database. Operations indicate the ability of a subject to either access or not be able to access an object, or even a subject accessing an object by a time or place or something of that nature. And then we have something called a reference monitor, and I will discuss that in a couple of slides in a little more explicit detail. But just as an example, let's say we have a company XYZ, and it has 4 employees. Alice is the accountant, Bob is the IT guy, Mary is the CEO, and Fred is the web designer. Now in this very simple example, there are various resources the company has, such as a financial database, an external web server, and an email server. So if we think about controlling access to these resources, how would we go about determining whether a let's say Alice, what she should have access to as an accountant. Well, if you look at the resources, maybe the financial database, yeah, that kind of makes sense. What about the external web server? Would she need access to that? Well, probably not, but regardless, her ability to access any of these resources should be defined explicitly in the access control policy as created by the company. How about Bob, the IT guy? Does Bob need to get into the financial database? Well, probably not, but certainly you might give him access to the external web server so that he has at least some control over that. Who else on that list of employees might we want to be able to access the external web server? Well, certainly Fred. Let's look at Mary, the CEO. What should Mary be allowed to access? Financial database, maybe. External web server, well, we might. It depends upon her level of sophistication and her need to be able to get into the external web server to make changes. And yeah, sure, maybe everybody on the email server, giving them, as we'll see later on, various levels of access to the email server. All levels of access aren't the same, as we'll see later on. But that's essentially what access control does, is it allows certain subjects to access certain objects in various levels of detail. Now, getting back to the reference monitor, what is a reference monitor? We talked about subjects and objects. In the previous example, notice number 4 down there, we also have an audit trail, which is a good idea. It's something that we'll learn and you'll actually see later on when you'll see that it's when a subject is accessing an object, it's good to have a trail, an audit trail, or a logging system that indicates whether that person was able to access the object. The reference monitor really ties in everything. It contains those operations and rules, as we'll see later, that determines whether the subject is able to access the object and how they're able to do it. For example, when we looked at the Linux administration course, there were really only 3 sets of operations that a subject could perform on an object. And specifically, we were looking at files. And what were those? Well, we had read, we had write, and we have execute, right? And we saw that sometimes a certain subject was able to read, write, and execute on a file. And for other files, they were only able to, for example, read that file, but they weren't able to write or execute that file. So all of that is determined by the authorization database, which indicates what the, let's say, I'm just using the term in general, rules that allow a subject to interact with an object. And that reference monitor is the thing that actually applies that to the situation. So just to be clear here, so the subjects are the system users and groups of users. Recall from the Linux administration course is you could put users in various groups, and that's how we were able to allow a number of users to be in a group, and then that group was able to access an object and perform operations on it. The objects are most typically files, but they could be other resources such as memory, printing and scanning, and even including other computers on a network. And an access operation, again, comes in many forms, including web access, server access, memory access, and even method calls. So let's look at the 3 access control models. We have the discretionary, mandatory, and role-based access control. Now, most of you are most familiar, if you're working with Linux, Windows, and the Macintosh, with the discretionary access control. So discretionary access control is based on the discretion of the data owner, and that's what we saw in Linux, is that when we created a file, we were the owner. And so the owner or the creator of that file specifies which subjects have access to that resource. If you recall, when we were creating files, we were changing permissions on the file. We could even change ownership of the file. And so that's the most simple level of access control. And an example of that is an access control list, which we'll talk about in a lot more detail a little later on. But suffice to say that Windows, Linux, and the Mac and pretty much any Unix with one stipulation, as we'll see later, implements discretionary access control. A more complicated form of access control is mandatory access control. And that's where the operating system makes the decision as to whether a subject accesses an object based on a security label system. So it's the operating system rather than the data owners or creators that allow or disallow granting access to the object. And the best example of this is what we see in the military, is where users and data are labeled according to a clearance level. For example, the confidential, secret, and top secret, which I'm sure you've all, or at least a little bit familiar with. And then we have rules for access, which are configured by the security officer and then enforced by the operating system. And when I'm talking about the operating system, I'm talking about that not only the authorization database that indicates who has access to what, but also that reference monitor that looks at the authorization database, as well as the classification levels of the subjects and the objects to determine whether access can be granted. MACs are used where classification and confidentiality is of the utmost importance, which the primary example would be the military. And generally, you don't see mandatory access controls when you buy a commercial system, when you go out and you buy a Windows 10 computer or the latest Macintosh, is that you have to specifically buy or at least implement mandatory access control. For example, with Trusted Solaris, or something called a Secure Enhanced Linux, which was created by the National Security Agency. And that's actually something that you can download from a website and implement on your Linux system. I would suggest that you do a lot of research on that and read up a lot about it before you do that, because it's a good way to lock yourself out. So all mandatory access control systems have a security label. And those labels, as we saw before, at least in the military, are confidential, secret, and top secret. And those security labels and the categories are typically defined by an organization, in this case the military. And there's also one more category which goes above and beyond the MAC label, and that is whether you have a need to know at a certain label, and we'll talk about that in a second. The question is, if we're talking about the security labels or security designations of confidential, secret, and top secret, if I have a top security clearance, can I see all of the projects in the secret level? And typically the answer is no. Is that not only must your security clearance be equivalent to that as designated to the object, but also you have to have a reason to access that information. You have to have a need to know. As we see here on the screen, we have the three security clearance levels, as well as the sensitivity designation of confidential, secret, and top secret. And so let's say, as an example, we have a, let's say for this example, is that you have a confidential security clearance and you need to look at a memo that has been designated as confidential. As long as you have a need to know, you're able to view that memo. As another example, let's say that an object has been deemed at this with a security label of secret, and you only have a confidential clearance. Can you read the secret level memo? The answer is no. Can you read the top secret level? No. So in other words, notice that you can't read up. Someone who has a secret level clearance cannot read a top secret memo. And I changed this to make this a little bit clearer, because actually I was trying to combine two separate concepts. So what I did was I paused the video and I changed what you saw on the screen, and I'll explain that on the next screen. So we see that we can't read up. So confidential can't read anything secret, secret can't read anything top secret, even though they might have a need to know for some particular reason. How does it work the other way, though? What this is indicating, that the arrows on here on the left, is that somebody who has a top secret clearance can not only read a top secret memo, they can also read a secret memo and also a confidential memo, as long as they have a need to know. Now think about producers of objects. That is now someone with a confidential security clearance creates an object somehow, and it happens all the time, that is later deemed secret. At the time they don't know that it's going to be classified secret, but they create one that's secret. And I've known this from personal circumstances, not me, but with other people. So somebody who has a confidential security clearance, can they actually create a document that is later deemed secret? Yes, they can. So essentially what this is saying is that you can write up. So you can create one that's secret, or if you're secret, you can create one that's top secret, or even if you're confidential security clearance, you can write one that's top secret. But guess what? You would no longer be able to read it. I'm afraid that's a fact. I know that sounds weird, but that's absolutely true. And this is just another graphical depiction of what you see here. And this is when we're talking about reading. And this also is predicated on the background that these people, these little icons here, are individuals who have, for example, here, a top secret clearance. This guy right here, this lady, they can read this resource, and actually it's kind of weird the way this is written. This almost looks like it's a write, but what they're talking about is accessing the server 1, which is top secret. So this person is top secret, so they can access the top secret server. They can also access this secret level server 2, as well as the classified or confidential server 3. And notice as you move down this hierarchy here, is that the secret clearance individual can access the secret and the classified, but notice that they can't read up. They're not able to read up. And a third type of access control is called role-based access control, and it's also often called the non-discretionary access control. And essentially it's creating a set of rules to determine how subjects and objects interact. And so users are assigned a role, and the roles dictate access to a resource rather than a user. And it scales much better than discretionary access control, because you don't have to continually change the access control list, which again I'll talk about shortly, or the permissions per user, nor do you have to remember what permissions are set on a new user. Just make them a certain role. For example, up here, let's go back to this example right here. And so so these are the roles here. Notice there's an account role, there's an IT role, there's a CEO role, and a web designer role. And previously we identified these users' access to these resources or objects down here. So what if later on Alice, who shouldn't be able to access the external email server, external web server or email server, moves to IT? How would we change this? Well, we don't want to go in and start changing the permissions on the financial database or the external web server, the email server. It's better to set up predefined roles that suggest that there's an accountant role, and all accountants who are a member of this role have access to the financial database and the database only. But later on, if Alice moves on up to be, and I say an IT guy, I use that in a general sense, and we hire somebody called Ted to become an accountant, well, we don't have to go back and change any of the permissions on any of these objects. All we have to do is to put Ted in the accountant role, and Alice now no longer has access to the financial database, but she does have access to the external web server and maybe even parts of the email server. And now Ted has access to the financial database. And you see how that works much more cleanly and scales better than the discretionary access control. And you can simulate this with groups in Windows and Linux, especially with LDAP and Active Directory. And roles are engineered based on the principle of something called least privilege, which you should have read about in another class and in your book. And least privilege just means that the user should only have access to stuff that they need to do their job. And that actually, if you think about it, speaks to the need to know idea as well. For example, here, what does Ted need access to? Well, the least privilege should be, in order to do his job, he needs to be able to access the financial database. He doesn't need, for his job, to be able to access the external web server. If he did, we could go back and change the role of accountant so that now the accountant could access both the financial database and the external web server if that's what they need to do. And so least privilege is a core concept in information security, and it's something that shouldn't be taken lightly. Let's go back here. So the role contains the minimum amount of permissions to instantiate an object, to create an object, or to manipulate an object. A user is assigned to a role that allows him or her to perform only what's required for that role and for nothing else. And no single role is given more permission than the same role for another user, and that's the whole idea. An accountant, anyone who's set up in the accountant role, should have the same permissions as every other accountant. If you had different levels of accountant, let's say an account one person who deals with the various aspects of a company, and then you have an accountant two that deals with other aspects, those would be two distinct roles. And one may be given more permission than the other, but everyone within the accountant one role would have the same exact permissions, and everybody in the account two role would also have the same exact permissions. So when would you use a role-based access control? One, if you don't need centralized access, if you don't need something as complex as mandatory access control, and of course if you have high turnover, if you're constantly churning and changing jobs in here. Let me go back here. If every 6 months these people are moving around or they're being fired and you're adding new people, rather than looking at a discretionary access model where you're constantly changing permissions here on the users and on the objects, all you're having to do is put people in different roles. You're either putting them in the accountant role or you're taking them out of the accountant role. Okay, now let's talk about access control technologies that support what we've discussed before in terms of access control models: rule-based, constrained user interfaces, access control matrices, access control lists, content-dependent access control, and context. Notice that there's an N here and there's an X. Content versus context. So rule-based access control uses specific rules that indicate what can and cannot transpire between a subject and object. And that is simply the logic that you've seen in your math classes or your computer science classes. If X, then Y logic. So before a subject can access an object, it must meet a set of predefined rules. For example, if a user has a proper security clearance and it's between 9 a.m. and 5 p.m., then allow access. Now notice how now our rules are becoming more complicated. Not only must the person have for example here, the proper clearance, they have to have a need to know, and now we're setting time limits. So that makes a lot of sense. For example, if no one is allowed external access from, for example, an external IP address to a certain database, and they're only supposed to be working during the day, then instantiating this rule here, 9 a.m. to 5 p.m., if that's their standard working day, and they're coming from the right IP address in the company, then they would be allowed access. Otherwise, they would be denied. However, rule-based access control doesn't necessarily deal specifically with identity and authorization. So rule-based access control is considered a compulsory control because the rules are strictly enforced and not modifiable by the users. So if you think about routers and firewalls we will look at in a little bit, you'll see how we will create rules that set up restrictions to certain objects. For example, a telnet server or an FTP server. What is the source address? What is the source port? We define rules based on that information to allow or deny access. And here's something that, if you think about access control technologies, we see all the time. For example, a constrained user interface. We can restrict user access by not allowing them to see certain data or have certain functionality on the computer. And this can come in many examples. For example, views only allow access to certain data, that is canned interfaces that only show a user specific information and they hide everything else to which they should not be allowed access. We can also give them something called a restricted shell. So and a shell is the terminal as we used in Linux administration and in this course as well. So it's like a real shell but only with certain commands that are enabled, like Cisco's. One that's highly restrictive is the menuing system, and we'll see it on a separate page here. But so now we're talking about a graphical user interface where we can give access to certain objects at varying levels of detail based upon that person's status in the organization, and that's all limited by the menuing system. And we can also have physically constrained interfaces that show only certain keys on a keypad or a touch screen like an ATM. So the difference is here is that users are being physically constrained from accessing, that is either viewing or manipulating the object. So if you see something like this, what is the user allowed to do on here? Well, it's constrained by the user interface, as they have drop-down menus where they're allowed to only select, for example, on these top three lines right here, they are allowed to select certain items. They're not allowed to select anything else. And the same thing down here. Now we're talking about numerical input, and that's constrained as well, and they can either click here or here, but this is all constrained by the user interface. So this is an access control matrix, which is a table of subjects and objects indicating what actions individual subjects can take on individual objects. So going down in the columns, in the first column over here, you see the roles: administrators, owners, guests, users, planners, and payers. On the top, going across this row, we have administrative pages, tax and plan, bill pay, public, account use, and account administration. So if we divide this up by rows and columns, we get either a capability table or an access control list. So let me make this a little bigger if I can. So a capability table is bound to the subjects. So now we're talking about this first row over here: administrators, owners, guests, and so on. And it lists what permissions a subject has to each object. So it's a row, and it's the opposite of an access control list that we'll see shortly. So planners have permissions to access tax plan, public, account use, and account administration. An access control list now looks in the columns. Now we're talking about lists, access control lists, what and how subjects may access a certain object. So now we're talking about columns. So the account use indicates who has access to this resource, which would be owners, users, planners, and payers. Another type of access control technology is the content-dependent access control, which is determined by the type of data. For example, email filters that look for specific things like confidential, social security number of images, and web proxy servers may be content-based as well. So it's based on the content rather than the particular role of an individual. And context-dependent access control reviews a situation, then makes a decision on the access. Now, when we're talking about the system right here, we're talking about still the reference monitor. And a good example of a context-dependent system is a firewall. For example, as we'll see later I know it's not going to make a lot of sense now, but there's something called a state table, which looks to see if there's a session already in place for the system, for the connection between a subject and an object. And if that connection already exists in the state table, then all other connections between the object and the subject for that session are allowed without going through the firewall rules. Another example might be allowing access to certain body imagery if previous web sessions are referenced in the medical data. So this was a quick overview of access control, and so you should be able to identify and define and recognize the following concepts. Constrained user interfaces, something we probably come in contact with every day. An access control matrix, capability tables and access control lists. Let me put this right here, that makes more sense. And content-dependent access controls and context-dependent access control. And we also discussed the 3 access control models, which include discretionary access control, mandatory access control, and role-based access control.